elevation in boiling point. Boiling point, what is the boiling point? The temperature at which the vapor pressure of a liquid becomes equals to the atmospheric pressure is known as your boiling point. Definition. Now elevation means what? Matlab, you have to increase the boiling point. So what is the definition of elevation in boiling point? The increase in boiling point of a solvent caused by adding a non-volatile solute is known as the elevation in boiling point. That means suppose here this is the vapor pressure, this is the temperature, this is y-axis, this is x-axis. Now suppose this one is the pure solvent, and the solvent at which the vapor pressure of the pure solvent is equals to the atmospheric pressure is known as the temperature, which is known as the boiling point of the pure solvent. So this TB naught is known as your boiling point of pure solvent. Now when we will add some non-volatile solute to the pure solvent, then it becomes your solution. Now if we add some non-volatile solute, that means to attain its boiling point we have to increase the temperature. Okay, that is why it is known as your elevation in boiling point. Elevate, you have to increase. So the boiling point of the solution becomes more than that of the pure solvent, and suppose this is equals to TB. Okay, so TB is known as the boiling point of the solution containing non-volatile solutes. So what is the difference between these two? The difference is known as your elevation, the increase in boiling point, which is known as your elevation in boiling point. This is equals to delta TB. So delta TB is the TB minus TB naught. Okay, now for a dilute solution we know that the elevation in boiling point is directly proportional to the molality of the solution. Okay, now if delta TB is directly proportional to m, then delta TB is equals to Kb into m dash, Kb into m. So what is Kb? Kb is known as your molar elevation constant or ebullioscopy constant. Okay. Now what is ebullioscopy constant or molar elevation constant? Now when the molality of the solution becomes unity, then delta TB is equals to Kb. Okay, that means the ebullioscopy constant or molar elevation constant Kb is equals to the elevation in boiling point when 1 mole of the non-volatile solute is dissolved in 1 kg of the solvent. That means the molality of the solvent is unity. When the molality of the solvent is unity, then the elevation in boiling point is equals to the ebullioscopy constant. Okay, is the unit of Kb. Unit of Kb is equals to delta Tb by m. Delta Tb is your Kelvin, temperature Kelvin, and molality is your kg per mole. So it is your Kelvin kg per mole. Okay. Now we know that molality m is equals to number of moles of the non-volatile solute divided by mass of the solvent in kg. Again we know that number of moles means what? Weight of the non-volatile solute divided by molecular mass of the non-volatile solute, that is W1 by m1, divided by mass of the solvent in kg means W2 divided by 1000 when you represent it in gram. So molecular mass of the non-volatile solute is equals to W1 by m1 into 1000 by W2. Again we know that delta Tb is equals to Kb into m. So we can put this value here. So from this relation we can calculate the molecular mass of the non-volatile solute, that is your m. So m1 is equals to Kb divided by delta Tb, W1 by W2 into 1000. That means there is a relation between the elevation in boiling point and the molecular mass of the non-volatile solute. That means they are inversely proportional to each other. That means if you will take a non-volatile solute whose molecular mass is small, smaller is the molecular mass, greater is the elevation in boiling point, and greater is the molecular mass, then smaller is the boiling point, elevation in boiling point. This is the relation between them. For example, if you will take urea, suppose the molecular mass of urea is 60, then it is the, and glucose whose molecular mass is 180, then lower is the molecular mass, higher is the delta Tb, and here glucose is higher is the molecular mass, lower is the delta Tb. This is a comparison between these two non-volatile solute. Okay, thank you.